Hello, in this video tutorial, we'll give a detailed description on the CloudSim toolkit and also demonstrate it by running an example. My name is Aparna. Let us first start with an introduction to the CloudSim and how to install it.
CloudSim is a toolkit or library from Cloud Labs for simulation of cloud computing resources. The official website for CloudSim is www.cloudbus.org/CloudSim. This website gives a brief introduction on what is CloudSim and its main features. Before we start with the features of CloudSim, let us first find out what CloudSim does not do. CloudSim does not support any actual software technology. It does not run any real applications, therefore we cannot run our project on CloudSim. CloudSim is a simulator, but it does not come with any UI and does not run our application. It's a library which is written in pure Java, so we will have to write actual Java code to use it. The main features of CloudSim are listed in this website here. It supports modeling and simulation of large-scale computing data centers. It supports modeling and simulation of energy-aware computational resources, support for user-defined policies, for allocation of hosts to virtual machines, and policies for allocation of host resources to virtual machines. Now this shows that CloudSim simulates cloud environment so that developers can concentrate on the main modeling and policy problems while ignoring the actual working of the cloud, and it also gives a performance evaluation for the models and policies. Now there is a paper on the architecture of CloudSim called CloudSim, a toolkit for modeling and simulation of cloud computing environments and evaluation of resource provisioning algorithms. Now this paper gives a detailed architecture of CloudSim, including the class diagram, sequence diagram and such. We can see that here. The architecture of CloudSim. The class diagram, and some sequence diagrams that shows the important features and activities on CloudSim. However, it does not give any details on how the simulation actually works, but it is a good start to learn to start using CloudSim. Now moving on to how to install and use CloudSim. There is no installation procedure for CloudSim. It is a package that we need to download and use it as a library in our project. You can find the page on Google Codes for CloudSim. Here there's an announcement that CloudSim has moved into GitHub, so we can also get the package for CloudSim from GitHub, or we can download it here. We'll download the latest version. Or we can also get it from the GitHub. You can download as zip here. Now once you have downloaded this package, you extract the files. Once we finished extracting the folder here, we'll use one of our IDEs to use CloudSim. Since CloudSim does not come with its own UI, it's always recommended to use one of the IDEs. So we're using Eclipse here, and basic knowledge of Eclipse is always helpful. So to start with, we'll create a new Java project. Call it CloudSim project. Uncheck the use default location, browse to your folder, and make sure that the JRE is at least 1.7, and then finish. On finishing, you will see the hierarchy of packages in the package explorer. Now CloudSim is ready to use. The source files are in the sources package. You can also run some of the examples here to see how the codes are actually written. You will have to add codes like these to use the source code given in these packages, or you can also write your own models and policies as given here, similar to these. Now that we have downloaded CloudSim and opened it in the Eclipse IDE, let us discuss about the framework CloudSim provides for simulation. For that, let us consider a simple example provided in the package org.cloudbus.cloudsim.examples, and let us consider CloudSim example1.java. This is a simple example showing how to create a data center with one host and run one cloudlet on it. Since creating data center with hosts and running cloudlets on them is the basic thing that happens in all simulations, this will help us understand the entire simulator better. Here's an image or diagram that will show the working of the simulator. The first entity to be created is the Cloud Information Service, or the CIS. It is a registry where the entire resources available in cloud are registered, such as the data centers and its configurations and properties. Next, a data center is created. As soon as the data center is created, it is first registered with the CIS. A data center has one or more hosts. The example we have taken has one host in it. Also, the properties of the data center are listed in the data center characteristics class. A host has a number of VMs. In our example, the host has only one VM. Also, hosts have hardware configurations such as processing elements, which can be 1, 2, 3 and so on in number, RAM, which can be 512 MB, 1024 MB or 1 GB, 2 GB and so on, and a particular bandwidth. After the creation of CIS and the data center broker is created. The job of the broker is to submit tasks to the data center. In the initial stage, broker communicates with the CIS and retrieves resources information from the CIS, that is resources such as the data center characteristics. The tasks which are to be run are called cloudlets. Broker directly communicates with the data center and assigns cloudlets to the VMs in the hosts of the DC. Suppose there are two cloudlets, C1 and C2. C1 is assigned to VM1 and C2 is assigned to VM2 by the data center broker. All these components, CIS, data center broker and data center, are called entities in CloudSim, and they work on certain policies. Data center uses VM allocation policy to allocate VMs to the hosts. Hosts use VM scheduler policy for processing of VMs. Uh, VMs use cloudlet scheduler policy for processing of cloudlets. We have all these entities and their behaviors in terms of classes in various packages of the CloudSim. So until now we have understood the basic framework provided by CloudSim. Next we understand the package structure of the CloudSim to understand the simulation in a better way.
Hello, I'm Anushka. In this part of the video, we'll understand the package structure of CloudSim. Let us see what different packages within the CloudSim does. CloudSim provides around 12 packages, which we can see here. The first one is our OR CloudBus CloudSim. The classes within this package, once it is instantiated, it will behave like some component in the system, or it will support a specific component of the system for producing a relevant behavior during the simulation process. The classes within this package is classified into two categories. The first one being the simulating component classes. These set of classes imitate a particular part of the cloud setup. The classes which belong to this category are cloudlet, data center broker, file, host, then we have storage, PE, VM. These are some of the classes which belong to this category. The second category is the policy classes. These are set of classes that imitate the policy behavior of cloud setup. Now the classes which belong to this category are the utilization model, which has three other variations which we can see here. Then we have the allocation policy class, we have the scheduler class, and then last but not the least the cloud scheduler classes which belongs to this category. Now let us see what each class within this package does. So starting with cloudlet, this is an extension to the cloudlet which stores all the information encapsulated in a cloudlet. Along with all the information, it also stores the ID of a virtual machine that is running it. The next class is this cloudlet scheduler class. This is an abstract class that represents the policy of scheduling performed by the virtual machine. This class is extended by three other classes, which is your dynamic workload, space shard, and time shard. These classes implement the policy for scheduling performed by the virtual machine. The next class is your const class, which stores all the constants defined within the CloudSim. The data center class is a cloud resource whose hostlets are virtualized, and this class deals with processing of virtual machine queries. Moving on to the next class, which is your data center broker class. It acts as a broker on behalf of the user, and it hides the virtual machine management as the virtual machine creation, submission of cloudlets to the virtual machine, and destruction of the virtual machine. The next class we encounter is your data center characteristics class. This represents a static properties of resource such as the resource architecture, operating system, management policy, cost, and the time zone at which the resource is allocated along the resource configuration. The next class is your data cloud tag. This class contains additional tags for data cloud functionalities such as the file information retrieval, file transfers, and storage information. Next class is our file class. The file class represents a physical file in a data cloud environment, whereas your file attribute class it's a class used for storing the related information regarding an entity.
The next class we encounter is your hard drive storage class. It's an extension to the storage class. This is an interface which defines the desired functionality of a storage system in a data cloud. This class is being extended by the SAN storage class and the hard drive storage class. The hard drive storage class basically is used to simulate the behavior of a typical hard drive storage, whereas your SAN storage class represents a storage area network which is composed by a set of hard disks connected in a LAN. The next class is the host. This executes all the actions which are related to the management of a virtual machine, whereas the host dynamic workload class is used to support a dynamic workload and performance degradation. The host state history entry is this class is basically used in order to store the state of the host, and we have the info packet. This class is used in order to gather the information from the network layer. The information can be something like the bandwidth or the round trip time, etc. Then we have the log class. This is used for performing login of simulation process. The next classes, which is the network topology and packet classes, these classes are used when there is a need to implement a network layer in a CloudSim. The next class, which is your parametric exception, is used to report a bad or an invalid parameters given during constructor. Moving on to the next class, which is your processing element class, is used to represent a CPU unit which is defined in terms of million instructions per second rating. The next class, which is your RES cloudlet class, is represent a cloudlet submitted to a cloud resource for processing. It basically contains a cloudlet object which has the information like the arrival time, the ID of the machine, or the processing elements which is allocated to it. The next class, which is your utilization model class, it is an interface and is consists of three variations, which is your full, null, planet, lab in memory. These classes are used to implement a control over the resources used by the cloudlet. The next class is your VM class, is used to represent a virtual machine which runs inside a host. Moving on to the next class, which is your virtual machine allocation policy. This is an abstract class and is extended by the virtual machine allocation policy simple. This class represents the provisioning policy of hosts to virtual machines in a data center. The next class, which is your virtual machine scheduler, is an abstract class that represents the policy used by a virtual machine monitor to share processing power among virtual machines running in a host. This class is being extended by three other classes, which is your space shared class, time shared class, and time shared over subscription class. Next class is your VM state history entry, which maintains the state of a virtual machine. Moving on to our next package, we have is your CloudBus CloudSim code. This package contains all the main classes of this project. The classes within this project is responsible for initiating, starting, maintaining, and ending the simulation process. The first class within this project, which is your Cloud Information Service, is an entity that provides cloud resource registration and indexing and discovery services. That is like when a host is ready to execute a cloudlet, then it has to register with this class. Or if a resource broker requires a list of resource IDs available, it has to get these information from this class. The next class within this package is your CloudSim class, which is used to enable the network simulation in CloudSim. This class is also used to disable all the network models from CloudSim to provide a simpler simulation of the network. The next class is the CloudSim shutdown, which waits for the termination of all the CloudSim user entities to determine the end of the simulation. The CloudSim tag class contains various static command tags that include a type of action that need to be undertaken by a CloudSim entity when they receive or send events. For example, we can see here is your register resource event, which is also being provided with a unique identifier. This class basically lists all the events that a CloudSim encounters. Next we have is a deferred and future queue classes. This provides a list implementation of the queue in order to store the events used by the simulation. The sim entity class represents a simulation entity, that is, it holds the behavior of the entity, whereas a sim event class represents a simulation event which is being passed between the entities in simulation. The next package we have is the predicates package, where we have classes that are responsible for selecting matching events from the deferred queue class for executing the event on a specific entity during the simulation process. Now this consists of a predicate class, which is an abstract class and is extended by all these other classes. Predicate any class will select any event from the deferred queue, whereas the predicate none class will not match any event from the deferred queue. We have a predicate from class which will select events from the specific entity, whereas a not from class will select events that have not been sent by a specific entity. We have the not type and type predicate classes, where not type will select the events that don't match specific tags, and type class will select events with specific tags. The next we have is our distribution package, which consists of these many classes. Now the classes within this package have a predefined network traffic distribution method implemented in it. For example, we have a continuous distribution or an exponential distribution, a gamma distribution, we have logarithmic distribution, a uniform distribution. Now whenever in our project we require to execute a network distribution, we can use the classes which are specified in this package. The next package which we have is our CloudSim list package, which has a number of classes that implements the predefined operations related to the component list during simulation. For example, the cloudlet list, it maintains a list of all the cloudlets that has to be processed by the virtual machines. The host list maintains a list of all the hosts, whereas the PE list maintains a list of all the processing elements that have been assigned, that is your CPU units area that has been used by each virtual machines. And then we have the RES cloudlet list, which maintains the cloudlet that have been already submitted to the cloud resource for processing. And then your VM list maintains a list of all the virtual machines. The next package we have is a network package. Network package consists of classes that produce a behavior which is related to the network packet routing. For example, if we take the Floyd-Warshall algorithm which is provided by one of the class, it is used to calculate all pair of series and predecessor matrix. Similarly, all the other classes, they provide one or other network routing technique which can be used directly in our project. The next package which we are going to see is the network data center package. The classes within this package produce simulation behavior for geographically distributed data center of cloud service providers. These classes is an extension to the classes which is available in the or CloudBus CloudSim package. These package add certain network specific features to the base class. The next package or packages, that is your power list and power model package. In these packages, the classes within the or CloudBus CloudSim are extended to produce behavior for power aware components. These packages can be used to implement green computing related work. The next package which we encounter is the provisioners package. The classes within this package is used during the allocation of a bandwidth or processing element or RAM to the virtual machines that executes the cloudlet. Here we have three base classes, which is your bandwidth provisioner, PE provisioner and RAM provisioner, which is extended by their respective simple classes. The next package is the util package. Basically, this consists of classes which measures the execution time and perform certain basic mathematical operations which is required by the CloudSim. To summarize all the classes which we have seen till now, here is the class diagram for the CloudSim simulator, where we can see the relationship between each classes, whether it's a one-to-one relationship or a one-to-n relationship. We can also see how the classes, how the derived class extends the base class and the abstractions between different classes. Hereby we end the brief description of all the packages within CloudSim.